Centralizing Repository Infrastructure. The whole project we were working on last years was about centralizing all the digital repositories into one. So it's not yet finished, right? But I think we laid some of the ground structures, and we pretty early decided to use Fedora. So why centralization? Just quick. All these digital objects that we have. I mean, I'm coming from a publication background, and but there are many other digital objects, like from the scanning of documents and books. They are similar in some ways: storage, dissemination, etc., processing, preservation, also compliance in the sense of when are objects allowed to be presented. But they're also different, especially when it comes to how they are produced and what metadata formats they use and all the media types they use and workflows, of course. But problem is that all this technological separation um, just produces multiple parallel infrastructures that have to be managed and developed and cared for. And we don't have the resources for this. Well, basically, we don't have the people. Um, so it's just increasingly difficult to do. And so the plan is to try to find a repository core that can just support all these different use cases. So why Fedora? Because there was a focus on infrastructure. It's an infrastructure tool service. It's a database basically, and it's designed around the concept of loosely coupled services. Right, there's a lot of services using Fedora, and the storage is of that's the main point for me, or one of the main points. The storage is independent from the metadata schema. So there's Fedora doesn't tell you on how your metadata should be looking like. Um, so Fedora concept basically is a web database from my view, and it cares about resources and fixity, and it requires a lot of surrounding. So and there was a problem in that about the ingest and dissemination performance. Some people, they found the ingest too slow. For us, this is not a problem actually. Also dissemination, because there's separate services for disseminating. What happened to Federation? Yeah, that's just from my notes. What happened to Federation? I don't know. So that was a key feature actually for choosing Fedora in the first place, Fedora 3 back in the day, because we have a situation where we cannot migrate content. It needs to stay on disk, on tape somewhere else, and we need to manage it through Fedora in some way, right? This is actually a problem that's not yet solved. And so we have multiple options for operating this thing now, at least for Fedora 4 and 6 now. There's Docker, Ansible, and cloud and everything we can use now. It's so up to date. We are still facing problems in this whole thing. Is like evolving metadata schemas, right? So we have a lot of use cases and users, and they have different metadata schemas, and the existing metadata schema is always evolving, which means we need to kind of version this, and we also need to involve it in a way that it's backwards compatible to some point. And if not, if this breaks, we need to do repair runs, and we do this quite frequently, actually. Um, Also, workflow semantics, they change and they are different from project to project. We have a multitude of media types. So we have PDF mostly for publications, but of course we want to store videos and audio, and a lot of research data is coming up recently. So there's like tables and images and things and that. But the presentation, I don't know who did it yesterday. We talked about that users expect software to be running in the repository, right? This is out of the scope for Fedora, certainly, but there are some requirements here, probably. And we have, this is the biggest one, legacy storage hardware we cannot change. I mean, it's not reasonable to do so, right? It's possible. It just takes half a year migration project where everything is offline. So this is a no-go, certainly. All right. So what is good about the whole thing is standardization, I think, right? Fedora now has a specification. It didn't start out with one, I think, right? And then the specification was coming up later. And this is really a great thing because we have a standard way of talking to a linked data platform repository now. And it talks about resources and RDF and relationships basically, and it's about preservation more or less, right? It's Fedora. Then there was Sword. Sword is the protocol for depositing stuff, basically, right? And the repository has to care about what this is and how it's to be done, and about ingest and also tracking and manipulating the deposit. This is actually new in the version 3 of Sword, and I think there's no ready implementation yet of Sword 3. There is one implementation coming up. It's developed by some Japanese informatics institute. I don't know what's the status there. It's a Python library, and I think the CERN guys are involved with the Invenio platform there. And then we have another standard that's not going to go away. It's OEI PMH. It's like really coming of age now, but it still works. It's so easy. So just like the original internet, it's so easy. Everybody can use it, and then history happens somehow. So, but the problem is OEI PMH is publication. It's just cares about metadata for publications, mostly, and it only handles XML formats, and it's not about integration like something on the web would be ideally. It's about collection. So all the harvesters like copying all the metadata, transforming it, putting it into their indexes, and then re-emitting it with some other interfaces. So reusing it basically, and one can use it for presentation though. So it's like if you need the your metadata for presenting, you can get it through this interface. So there's some sort of standard. We have a lot of formats that we use. Mets mods, that's great. We can describe a lot of stuff in Mets mods. Everything we cannot describe, we just put there as an extension. This worked out so far. Then there's another stuff, TI and this triple IF is coming up for the images. Those is pretty common now. And we have PDFA for publications and all these different formats that are actually possible to archive. So this current architecture overview is from 2014. I just copied it from my slides from back then. So it's basically still this architecture in our production system. And there's Fedora in the middle, and of course, and there's Typo 3 in the back, in the front end, and in the back end there's OAI and SORT APIs and the internet and so on. So, but this change, I think this has to change a lot. Uh, so I will just quickly go over our front end because we have a custom front end, which personally I think is a bad decision to program a custom front end. So if you don't have any crazy requirements for your metadata or workflows, don't implement your custom front end. It's its own project. So what we have one, of course, it's a Typo 3 application, which I also don't recommend. But mm, we have an interesting prototype here, basically, because it's fully customizable in terms of the forms you can put in there and in terms of how the metadata is generated and stored. Um, so if somebody is interested in this, just have a look there. It's still developed. We are developing it further. We're not giving up on it, but we are about to improve it a lot. So that's our front end. Now we have this usual and well-known mode of running a repository where you have production and you put everything that is produced into a storage, and from there it goes to preservation to not to be seen again, and it's used out of the storage, right? So that's the ideal picture that also some people I think still have, but reality looks more like this. We found out, right? It's like storage and preservation and use, they kind of influence each other. It's like the production is so how you produce things is influenced by how you can store things, right? You cannot just store everything, and how you use things is already like influencing how you want to store it because you need to disseminate it. Especially preservation is like influencing everything. It's like how you store the things and how you manage the data, and also how you produce it, because you cannot preserve everything. This is really complicated to preserve stuff, and so this is a workflow already in place right now. We go out to people that want to produce things, and we say them to them like, produce it this and that way so that we can actually archive it, right? Otherwise, there's the separation that some people don't make, is like bitstream preservation, where you just keep the files as they are, and then there's preservation where kind this file is transformed over time to be so that the content remains usable. All right, so future architecture components. The last 4 minutes. Yeah, I have to rush. Uh, we just
Oh, you still have
um,
time. You started early,
okay.
so
I just
okay.
we split up. So we split this in these different components, and this is the basic idea. We have a repository that contains everything that needs to be archived. Also, the objects that are built up to be archived one day. So there's different states. Then we have some sort of storage where we just put any processing data just to be used later from later processing. And we have disseminations. I cannot give up on this term. I'm so sorry. It's just it just expresses what it is so well. So it's generating views and derivatives of whatever object you have there. And these disseminations are also saved in the storage for later use. And then in the center of everything, not in the center of the list, but in the center of everything is a message bus. So we have a distributed and persistent event system there. And because historic events are valuable. So it's like connecting everything with JMS is not sufficient in this idea. So we have feeder and provider. This is an interesting concept. There are always pairs of feeders and providers. I talked about this yesterday briefly, where we said I have a provider, and there's like an OAI provider that provides the OAI interface that you can extract records from, and we have feeder on the other side that actually generates these records and stores them so that the provider can just disseminate them. And this is a general concept here, because we can have a lot of providers. One example would be reporting. There's one reporting database. It's basically just a Postgres database, um, just collecting a lot of data about objects moving in and around the system. And the feeder is everything. It's like feeder is a component extracting events that happening in the system and writing to this database so that it can be queried later. It fits to this model as well. So also an interesting provider would be sitemap. We have a sitemap provider. It just generates Google Sitemap XML. This is a special format for websites that Google can actually index the websites. And I also have a feeder for this. So the feeder extracts the URLs and then generates the sitemap. And the provider just provides the XML. So future architect components number two. There's a little bit of a graph here. Of course, we have the repository. The repository is interacting with the message bus, because if something happens to the objects, there's a message. Then we have storage. Storage was this volatile memory kind of cache thing. If something happens there, it generates an event. Of course, we have the feeder components. The feeder components react to these events eventually, and produce data to write into storage or to feed it to some provider. And then above there is these three components that are actually kind of influencing everything here. It's production. So how is the data produced? The repository cannot know. There are so many different systems to produce the data. It really depends on what it is. But it stores all the stuff in the repository and retrieves it from the repository directly. We have use. So use basically everybody that is using the provider, like the OAI harvesters. They are using the provider to get the records. And preservation is a bit problematic there, because preservation is also using a provider, extracting archival units, or we say intellectual entities. That's a packaging format, if you want, for all these objects. And then there is this one line, there's a little bit dashed line there, right? Going from the preservation back to the repository. This line is an actual problem. We haven't implemented this yet. And there's also basically it's technologically it's not that much of a problem. It's really an organizational problem and a conceptual problem. So let's get back to messaging and events because there were questions yesterday about this. Why messaging and events? So resilience. It would be nice to have all these messages running around in the system to be available for everybody. It doesn't matter when the processor or the consumer of this event actually comes in. Right. So the consumers basically are tracking repository content or any other events, and they may be down when the event is actually emitted. So they come back online and want to have this event. They may not be have deployed at this time actually. So I'm just developing something new and deploying it, but I want all these historic events to be processed, and there might be a new version. It's like I have a new version of this component. I want to see how it behaves so I can kind of replay all the older events to see what's the actual result. Um, we have a little topology of these events things. So distinguishing between process results. This is so some data pipelining process results. Service configuration would be something like a service is configured and changes configuration for anybody who needs to know. Service control is actually a command control pattern. So you can really like send a control command to some of the services in this topic. And service events is like everything that is happening. For example, Fedora change events are service events. Like my resource here changed. Here's the URL. Here's what happened. And there's a JSON schema for these messages because they're all JSON. JSON, what is JSON? And posted to Kafka. And there's a schema for this. And you can have a look at this here at the GitHub repository. Data processing, we are evaluating data processing there. So we use Camel in the beginning. Camel is a really great tool, but you need to do some programming there, right? So, and you need to really have to have the components there, and it has its own caveats. So I was looking for something that is more like graphical. It can just scale for me, and I can easily deploy. And I was looking at Apache NiFi and made it actually in this way that it's running right now. NiFi, it's an interesting tool, but it's also very complex. It's very capable, but it's not easy to set up and actually manage, I think, right? So that is an easier one that I just recently discovered is Apache Airflow. Everything is written in Python. Even your pipelines are written in Python, and you can easily monitor them. And we are evaluating this right now, trying to find a way to work with Apache Airflow. Okay, so I briefly touched this storage, preservation, and use. This is not enough, right? We have data management, legal issues, and translation, and conceptual mappings, and everything that is happening there. And all the data that is actually put into storage needs to be processable somehow. So there's like, I don't know, machine learning if you want, right? Also, what is very interesting so for people's queries. So you want to really kind of be able to set up like search index or any query machine or triple store that can actually query the data in the ways that you didn't, foresee. And then the biggest thing, long-term preservation is a change of ownership. I really had a hard time to get my head around this, but this now I think it's stuck. Um, so I'm telling everyone, change of ownership. It means if you give an object, an archival unit to the long-term preservation, you are not longer in possession, right? So the archive is. And if the archive decides that it changes something, you are responsible for getting it back from the archive and working with the change, right? So I can get into more detail maybe in the questions. All right, so all of this is a matter of organization and workflow implementation, basically, right? So, all right, and I finished slightly over time as usual, I think. Thank you very much.
No, actually, you're right on time.